Yeah, I'm going to remove
Okay.
this first.
No,
Hello, welcome to DevKami number 123. So I'm swimming.
I am Tristan.
Yep. Below is
John.
Sean.
Hi.
Then Stanley is our guest throughout the
I'm
series.
I'm Chile. I'm going back
Yes.
off.
Yeah. He's behind the scene because he don't like the layout. So that's that. So today is our second. Okay. So because we have a lot of topic, I'm going to be a bit quick. So this is actually our number 2 episode on our embedded programming episode. So today we'll be covering the basics of electronics and all that. There's a reason for that, but before that, I think let's go through quickly about the events and our bus corner. So, oh, I'm so sorry. I should share my screen. You see my porn now. Just kidding. Let's start with meetups actually. I forgot about meetups. So we have in early morning Malaysian time we have Flutter Engage. This is an event where you meet at the global Flutter community, and there's a big Flutter news today. More on that later. So next week Monday we have HackerDesk Tech Meetup APAC. By experience level. So if you actually registered, you can go in on one-on-one session and all that. So if you're interested, go on. Then Rust Meetup is 4 days before Pi Day on March 10th, and I think that's about the event next week. Of course, Pi Day is on Saturday next week, I believe. Sunday next week. So yeah. Any event that I missed?
No.
If not, let's move on. So the first one on our list is another super alternative to Auth05 based out and Cogito. This is this open source called Super Token. Of course, there's a hosted forever, but you can if you do self-hosting.
The reason why it was shared is Okta just acquired Auth0
Yeah.
for 9 billion, if I remember. That's
Yes.
It's a crazy number.
6.5 billion.
It's still very
6.5.
big for us.
Still a crazy number.
Yeah, but Auth0 had been a key infrastructure that people rely on, so it probably worth the price.
We're gonna touch it. Seeing 1 NDP is almost a number of that.
Yes, correct. So there's integration and all that. The link is on DevKami.com, episode 123. So let's move on. So this is Traitor. This is actually a Go-based tool to actually do privilege escalation, and they're actually based on the list that is provided. So you update it, you will get it. So you can actually, it's pretty evil. But
It's
fun,
actually
so.
like a fuzzer for privilege.
Yeah.
Okay.
So if you want to actually break a system of your own for testing, you can try this.
Yeah, but your server is my server, right? So it's my own server.
Yes. If you use VMware vCenter, there's a big security issue. Double check if you actually got update, because this is actually pretty bad. This is actually pretty
did you
bad.
read it? How bad is it?
The rating is 10.8 by 10. So it's actually in the water. So the vulnerability is out there, is being exploited. The severity rating is very high. And yeah. And there's a mass scanning activity, so it's actually being used right now. So, and if you're on enterprise data center and all that, too bad lah. It's one of those things lah. So let's move on, because we got a big topic today, so we hope to cover it very fast. So it's not Go malware. It's more like malware is more commonly is now being developed in Go, and it's adopted by both the big evil guys out there lah. So it's And in fact, it's up by 2,000%, so it's more commonly used. So yeah. So if you know Go, so you do not need assembly like of the old days to actually
Also,
write
Go
libraries.
does produce a pretty big binary, like
Yeah,
5 meg at
correct,
least.
correct.
But these days, because of internet, everywhere has internet,
Yes,
everybody has fat pipes.
yes,
It's not.
yes.
I don't know. I
Because
familiar.
those days, in the early days of virus had to be small because you cannot have a big packet that too big it will get big. Nowadays, you can get a 500 megabit like me, or you can get 100 commonly, or even 30, which is pretty fast. So you don't. I mean, Go doesn't produce 100 megabyte packet payload. Okay, so it's still reasonable for down speed, so which is why you don't really care anymore.
The file
It's
size is
more
still
about capability.
noticeable. The
Yeah.
file size is still noticeable, but
Yes.
insignificant with our fat pipeline.
Correct. So yeah, be careful out there and all that. Maybe you cover this one day. Python developer survey result. From what I see, it's just nothing too special from last year. Data analysis, web development, machine learning, more web development. Nothing special, but it's not too different. More application development.
And
So,
Pipe 3.10 is now in alpha.
yeah. Oh yeah, and that
Pipe
actually have pattern matching, which is awesome, and a lot of stuff. So I'm looking forward to the upgrade, and which is a good
I'm
thing.
not that impressed. We do that in the other episode.
Yeah. This is actually the Microsoft Power Automation tools. This automation tool for the desktop, Windows desktop, used to be not free. Now, if you're on Windows 10, you get it. It's actually had all sort of automation with 300 action and all that. Very interesting. If you're testing, I think you can use it for your browser as well. But you want to use it for what we call RPAs, robotic process automation. It's possible as well. I do not know how well you can script it. I don't have a Windows machine to try, but one day I want to try this. It looks interesting. So if you look at the demo, they actually have a web page. So of course you can use this for QA or browser and all that lah. So yes. Then the last one is Flutter 2 is out. Pretty sudden. So let's see. From what I see from the post is they're actually saying that who uses it and all that, and what is capable of. I don't any actual interesting thing.
The main thing is the API. The C API is now stable, so that's
Okay.
why it's a major release.
Yeah, and you can if you're on Linux, mostly Ubuntu actually. If you're on Ubuntu, can only catch you supporting Flutter for other
Ubuntu is
application.
also announcement from Ubuntu that they're gonna support the Flutter to do the front end desktop apps.
Correct. In theory, you can use it for other distro, but this is
and also
mostly,
contribution from Microsoft to support the other form factor like
Correct.
Surface Duo.
Yes. So it's interesting. I actually like Flutter. I played with it. It's a bit the thing.
Flutter,
My only complaint. Go on.
Go on first.
Also, the only thing I don't like is the fact that there's a lot of layout. It makes sense, but because the way application layout nowadays, you have a lot embedded layout, it get really confusing. But there's way to make this more organized, which I really enjoy. So yeah, but on the other hand, I also jump straight into a complicated project. So
we are back to that circle again, or the cycle again that now we are specializing each tool separately. Like we don't want to build everything in one language and framework. So Flutter, for some they use. I mean, even for I know that some mobile developer even they write a backend service, then serve the front end via an RPC or something like that. So which is most Linux app been doing for been so long already, via sockets.
Correct.
You don't need to really write everything in one.
Yes.
And hopefully
So,
that
yeah.
will increase some more desktop apps for
Yep.
Linux, that's especially
Yep.
Ubuntu. And also,
Yes.
I think Electron hater will celebrate. I'm not sure.
Yeah. Apparently, a lot of people
But-
celebrating the death of Electron. I have my doubt. But it is what it is. I'm looking forward to playing with it. And that's Buzz Corner. And we do it within 10 minutes. Woohoo! Which is good. So, now let's talk about our hardware hacking episode, which is how should I start this? Oh yeah, first I need to stop screen. So here's the question I will need to ask you guys. How do you? So let's say you had an idea. Let's start at high level first. Like you had an idea of a project, right? You had an idea for a project. How do you start for a hardware project? How do you start first? So let's say you found this cool sensor, right? This cool sensor. The sensor are not in a very modularized form, meaning it's not in a form of groove connector. So meaning you have to set up all your supporting circuit for power.
I'm not sure if we should start with a sensor though. Usually most of the projects come because there's someone's paying you to do something, not because you found a cool sensor.
Okay, but for our audience, okay, fine, because from what I see right now, because a lot of people, me and so more people among our audience are not engineers. We are more like hobbyists, right?
Well, let's check with Stanley, for example. Like, let's say someone approaches Stanley for like a project. What are the things that you actually ask them for?
Yeah.
Aside from the budget.
Yes.
Actually, probably the first I will ask them is like, how urgent you need this? Because I've done, I think some projects like 2 months, and then some like can go down to like longer, like 6 months. Like if you want it to be done in 2 months, I'm not going to start from scratch, things like that. And then
so is there going to be a difference in like the 2 months and 6 months, like the choice of things that you actually do?
Oh yes, of course. Yeah, because if you want it to be like a 6 months one, you take more time to at least like get it properly designed, and then of course you ask them things like how many units you want. You want 10 units, or you want like 100 or like 500 units. So the decisions to those are very different. And I think one of the fastest I probably did was like 2 months. Then after that, you write all the software and everything. Yeah, but I think in today also, because of the Arduino platform and things like that, right? In the past, where you write the hardware itself, and then you have to then spend a lot more time to write up the software and the drivers and everything. These days, with a lot of the Arduino side, I think the expectation also like they want it a little bit faster. My last one was like, I told them I need 2 months to iterate through the printed circuit board and such. Right? They say that they don't have that amount of time, so we just they just go and get one of those ESP and then start coding.
Right. How about integration with whatever they need? So for example, let's say you do LED before, right? The lighting system. So how the integration or how do you start doing what the thing you need to integrate with those things? How do you know the component you need and all that?
If it's things like sensors are these days are quite straightforward. Just typically nowadays I just use I2C. Like all the sensors, and I have like all the I2C marks and hubs and everything for that. If you want to do things like maybe LEDs and other things like that, right? That would be a little bit more time. But the end of the day, I think toughest is probably if you want it to be battery powered, because you have to like test all the battery and make sure the battery lasts, things like that.
Okay. So how do you? Okay. So what's the resource? So let's start process now. So let's say we're going to skip the fact that it's existing module, meaning anything that already have I2C or serial. Those very likely already had all the things set up for you, all the circuit already set up for you. So we're going to skip that because more of those are for those that actually for some of you guys that actually new to hardware hacking. Those exist, but let's say we had some very exotic one. How do you get started then? Do you go through the data sheet first?
Yeah,
to get the spec?
Most of the time, probably we start with the cost first, because some of them, if they are very price sensitive, I always share that you can get a 10 ringgit sensors and a 1,000 ringgit sensors.
Right.
Both of them do reading, but of course the reading they get is a bit different, and
Yep.
the longevity of it is very different either.
How crappy you want it to be, lah.
Yes, and there could be a balance, I mean, like maybe they're okay with a 400 ringgit each sensor. You don't need a 2,000 ringgit sensor, that kind of quality. Yeah, but they do like humidity sensors. They do make a big difference, because like they could run by like 10-20%. Those are really bad sensors out there.
Right.
Do you charge for calibration as well? Like, let's say humidity, right? Like, I need to know whether it's from 40% to 60%, it's accurate up to 95%. And then outside is, I don't care, maybe up to 80%. And then like really extreme with like, I don't really care about accuracy. Do you do that kind of calibration?
No, calibration is, there are a lot of test labs that you can send for calibration. Typically they are not cheap, and also on the point about the hardware delivery, right? And if you need to like get like SIRIM approval, or if you have a RF board, right, you would need to send it to SIRIM to get your type approval done. Those are if you have any radio related boards, for example, Bluetooth, Wi-Fi, or GSM, or things like that. Yeah. So those are the last steps of the process. Yeah. Those needs to be considered. Like why you wanna why have a single band instead of a quad band? You're gonna pay like 4 times more for your SIRIM testing. Yeah.
Right.
Yeah.
Okay, so you go and get the cost. You decided a sensor. Then you're going to, after that you're going to assemble, or you're going to. So are you going to assemble it, or you're going to just start with prototyping with Arduino first, right? How do you process? How's your process like?
In the past, usually you do a breadboard or prototyping, but these days, because the PCB houses are so cheap, and typically you can get them back within a week, right? Some of the time, like forget about wiring, just while waiting for the sensor, get a EDA tool, draw the PCB, and then just produce one PCB and then ship it out, and get it back almost within like fastest I got is probably like 5 days. So go on first. Yeah. So I mean, like nowadays I don't even bother to do a breadboard anymore. Just once they have a kind of like a rough idea, spend a little bit more time and do it. If the board has some error, just iterate away. So kind of like doing it is because of the cost of making a PCB is so cheap. A lot of the prototyping step, because the reason in the past people do spend a lot of time doing prototyping and simulation and things like that, right? Is because the cost to produce the hardware is very expensive, and then nowadays it's going to be so cheap, right? If the board have error, just throw it away and make a new iteration. Yeah.
Okay.
So that's how it goes.
Okay, so what's the tool you use to actually design the circuit board?
I usually use KiCad. KiCad is an open source EDA tool. It is available for Windows, Linux, and Mac. So I switch between Windows and Mac. So it's actually a pretty version 5 was one of the game changer. Very, very easy to use. Prior to that, it was pretty confusing. Well, I mean, like they are very much professional tools like Altium and things like that. But then those are slightly a bit, probably the starting licenses is like $10,000 US.
Yes. Yes.
Yeah.
Okay, so what do we need to know before we use this software?
Well, I mean, like I guess some sort of conceptual things about what are all the ICs and what are all the parts, and but they are typically if your middle part is like an Arduino or ESP, right? That is the first board footprint you get, put in the middle, hook them up with all your sensors and all your connectors and all the other components, right?
Okay.
You're almost like, I would say, like 50% done.
So, okay.
Yeah, I'd like to check with Sean, like how different it is with designing with FPGA, because I guess the FPGA can do a lot of things that you'll have to buy actual peripherals for if you do start with an Arduino, for example. Like how different is it?
Well, if you are going to be designing with FPGA, some of the things that, of course, Stanley said is still applicable, like for example, the general process and all that. If you are going to, like for example, build your own FPGA board, right? It's still, you have to design your own PCB. Of course, it's going to be a bit more expensive building an FPGA based PCB than a normal PCB, just simply because FPGAs have a lot more pins. So you will need a lot more layers. Like you can have 484 pins on an FPGA. You can't just route them out easily on one layer.
You probably can't solder them yourself, hand solder them.
You can't solder them yourself either. You can't self-assemble, you send it for assembly. So the part where Stanley said about PCBs are very cheap, you can iterate, throw away very fast. That doesn't happen in my company. I'll scold the guys if they make mistake for PCB, because the PCB costs more than their salary. I fire them and throw the PCB away. Yeah, but yeah, so there's of course some levels of differences if you're working with FPGAs. But generally the idea is still correct. Like for example, when Stanley said he used KiCad to do PCBs, we use KiCad as well, right? So even to design our FPGA PCBs as well, also use KiCad. But like what you mentioned, Tristan, about modules. If you are working with normal microcontroller, like whatever, you have limitations on the hardware, right? Your hardware has like certain number of UARTs, certain number of I2Cs. Like Stanley said just now, he has a lot of I2C hubs and switches and all that kind of stuff. If you are working with FPGAs, then of course your scope is wider, bigger, right? Because a lot of the hardware can actually be implemented on chip, so you don't really need so many things outside of the chip. Like one of the boards that we designed last time, we actually did quite a beautiful board. Of course, it was a bit stupid in terms of money-wise, but it was quite a beautiful board because we made it so that on one side of the PCB, there was only the FPGA and nothing else. That was purpose of artistic purpose. So that's very stupid because you only put one thing on one side, then I wasted the whole money to assemble the whole one side just with one component, right? Yeah, but it's artistic now. Then on the other side, we only basically had like passives. On the other side, it's basically just passive, so resistors, capacitors, and stuff like that, right? Okay. So in what I was trying to get is that we actually, because it was FPGA based, so a lot of the extra ICs and modules or whatever that you usually have surrounding your main microcontroller or whatever, it was actually all in the chip, right? So it was quite useful. We had one extra IC at the side that's to help boot up the FPGA, so one microcontroller, but that was it basically a clock, microcontroller, and the FPGA, boom. And all of the functionality was actually implemented inside the FPGA. So in terms of that, the hardware side, I think quite similar to what Stanley has said, but at a slightly different level. And if you are working with FPGAs, the speeds that you're working with may also be different. If you're working with Arduino, it's a very simple 20 megahertz chip. You don't really care about high frequency signals and all that. But if you work with FPGAs, depending on what kind of applications you're working on, you can have like gigabit signals running at the I/O, right? Some high-speed serial signals. Then you need to be a bit more careful when laying out your PCB board as well, because you're dealing with high-frequency signals, right? But otherwise, there's also an advantage to using FPGA because like the clock signal, if you really want a high-speed clock signal, we can actually synthesize the clock signal internally in the FPGA, rather than having to have put a high-speed clock outside on the board. We put a low-speed clock on the board, but then we synthesize the internal clock signal inside the FPGA. So in that sense, it can help as well. But yeah, so but besides the physical aspect of designing a PCB board, you also need to do your HDL code, your Verilog or VHDL, right? To actually all the hardware that you want to implement, you actually have to have the code to actually implement it. So you also need to design your hardware, quote unquote, in using code, right, for your hardware, and then you have to design your software as well. So that's usually what we call hardware software co-design. When we say hardware software co-design, we actually mean the FPGA as well as the FPGA code as well as the software code as well. So it's a little bit more involved in the sense that you've got to have validation, right? Testing and all that. You have a bit more validation to do, because it's not just testing the software whether it works or not with your existing hardware. You actually have to also test the hardware and test the software. The hardware designer, the HDL, have to test the software, and then I have to test the physical hardware as well at the end of the day.
Which tool do you use for the VHDL and the Verilog creation?
Okay, so that in the past, okay, let's say don't say not very long ago, 2 years ago. Okay, let's say 2 or 3 years ago, 2018. 2018 was the year that things turned around, right? But prior to 2018, so more than 3 years ago, the software that you have to use would actually be vendor specific, vendor dependent. So in other words, if you were using a Xilinx FPGA, you have to get the Xilinx INC webpack, use the Vivado or whatever from Xilinx. If you're using an Altera or Intel/Altera FPGA, you have to get Quartus and so on. So it was very, very vendor specific, and they would have their specific tools, their specific tool chains. Of course, they have the free version which you can use for simple projects below a certain level. That means certain level meaning that how complex your FPGA design is going to be. If it's like 100,000 gates or 500,000 gates or what. So their software is limited that way, the free version. So it's for small projects can use. But the moment you start to build more complex projects, you are talking like million gate level designs and so on. You have to then fork your money out to buy and as usual, it's not going to be cheap right? So it's worse than your PCB design software right? It's even more costly than that. Yeah, so there's that will go up. The cost will go up, right? But that was 2018. Prior to 2018, in the recent years, especially in the last 1 or 2 years, the open source FPGA tools have matured quite a bit. Of course, they are still not yet fully matured. So like, as in, there are many steps in designing FPGA. So there are different people tackling different parts of the problem, right? So synthesis is one part. That's just one part, right? Then there's the place and route mapping, and a lot of other different parts, the different steps of it. So they are like different people working on different parts, and then they are trying to make them work across different types of FPGA, the hardware from different vendors. So there's a lot of effort. The point I'm trying to get at is, in the last couple of years, last 2 years or so, there has been superb amount of effort up to the level where today it is possible to entirely implement the whole thing, a whole design, every single step using open source software. Free and open source software. So you no longer need to rely entirely on vendor provided tools. And in fact, some vendors, a couple of vendors have embraced this. The smaller vendors are not the big boys. Big boys, but the smaller FPGA vendors, they have embraced it, and they're supportive of it. So they are like helping out, contributing, providing documentation, stuff like that to help the open source guys to make the tools work with their hardware easily, so that you can easily design something and implement it on their hardware, their FPGAs. After all, they are making money by selling you the chips, right? So the software licensing to them is not so big an issue, right? But of course, the big boys know,
Okay,
big boys
cool.
need everything
So,
hidden.
Yeah.
Yeah, Sean. I think nowadays the about recent news about all this like trade war between the China and the US, the three big boys, the three big US FPGA. Right? How close are those China FPGA relatively to the at least the smaller ones are, at least Lattice or whatever. How close are they? I mean, like the China side.
I've actually been exploring this as well, right? Because like I mentioned last week, I'm writing a book on FPGA design. So I've also been exploring the differences between the different FPGAs from different vendors. And the Chinese ones, as a general rule, are one generation behind.
Oh, that's not that far away, actually.
Not that far away, correct? They are pretty much about one generation behind. So, but the especially if you compare against the big boys like Xilinx and Altera, they're definitely behind. With the small, even if you compare, like let's say Lattice, also depends on which particular product line in Lattice. But they are generally, like I said, the Chinese one is one generation behind. But feature wise, also they are also behind. And in terms of software, the capability of their software as well is also behind. So actually, I would think that it would actually be a good idea for these Chinese guys to actually just embrace the open source movement and just support those guys and let them.
I have a question. What is a generation in human years?
Okay, that's a very good question. All right, so I think roughly a generation would be probably. Let me think. Probably close to 5 to 7 years. So maybe close at almost at 10 years behind so to speak why I think about this, because I'm trying to think when was the last time I used when was the time I used this generation. I was thinking 2003 I used this generation, 2008 or 2010 I used another generation, now I use another generation, right? So it's about 7 years the life cycle.
Okay. So I'm going back to Stanley. More basic question. So now you got the PCB out. Then what? So when you know KiCad, then you're going to learn a bit about electronics, meaning you essentially say what's the component should go to where, right? So you got your PCB after 5 days. Then what? What next?
While you wait for your PCB, that's where you quickly order your components needed for your boards. Typically all the common ones, and and also I think it does speed up a little bit, because as we start using surface mount parts rather than through hole, right? That speed up a lot of the process. Typically, once it's in, so you have around 1 week to order your sensors, your components, or whichever parts that you want to do, and then once everything probably take a few days or at least a week to solder them up together, get it tested. Once the circuit is okay, then only you start writing your software for whatever their requirement. Typically, they will have a lot of could be weird requirement, like they say, okay, I want the sensors to be waterproof, the casing to be in another box, lots of things. One thing that very not so known but very important is actually the different types of connectors. So it's like all your external connectors, and then they are like gazillion type of connectors out there.
Yes.
You find a 2-pin, 3-pin, like you say the groove is a 4-pin connector, and then there's like the PH, the XH. They're all like very similar, but they're just different, So Of course, after a while, you standardize on your different type of connectors so that you speed up the part of it. Yeah, that is the one that connects your PCB, your board, to an external stuff lah. Typically, either battery, sensors, or maybe to another board. I think, yeah. So I felt that.
Go on.
Yeah. So the connector part was important because then you have to decide what sort of casings and I think that. So for very very quick prototyping, you probably just use a project box and then shove it in. So but that board itself could be quite I would say usable, especially if you're going to do a lot of IoT stuff. Right? It's actually quite usable, and then you could make a few of them, maybe 5 or 10 of them. The one I did was like I have to do like 20 bots. So then I just get somebody else to get it to solder them. Typically, if you do, there's one more step which usually I don't do it that often. Is what we call they will do the soldering for you in the factory, but that steps was a little bit more detailed because you have to tell them where are the parts, and then you have to do a lot of the steps. So I find Malaysians because I'm a ham operator, I know a lot of people that can do pretty good soldering, right? I just like send them 20 bots and then pay them the whatever fee, and then I get it back probably within 2 days. So some of this you really speed up some of my the process. Yeah, because if you need to solder 20 bots, right? If I were to do the soldering and I have to do the writing the firmware itself, that's gonna take a long time. Right? So I do outsource some of those parts out there.
Okay, so before we go so far, where do you buy your component?
Nowadays, I think that there was this website LCSC or like typically the common one are like Element 14, RS Online. These are the place. They are not the cheapest in the world because anyway I'm buying quite small quantity. So just order them, and typically the good thing about Element 14 is like the shipping is free. So you could buy like I don't know 20 ringgit worth of things and the shipping is still free. So there is something pretty good.
We don't buy anything, also we get something free. Ignore me, we're crazy. That's for the competition. I still need to get something done for it. But okay, you need to remember, you're not talking to me, right? A lot of the audience are actually software engineers, meaning they have no idea how you buy stuff and all that. So
okay. The Element 14 one, typically they have this parametric search. So what you do is you will key in your whatever parts you need, say a MOSFET or resistor or some transistors, right? And then you narrow down by brand or by number of pins, either it's through, and then of course you pick either the most popular one or you pick the cheapest one that meet your requirement.
Okay,
I would suggest Digikey as well from Element 14. It's not free shipping. It's only free above 250 ringgit. But if you're getting it for like a project that you're doing for production, then most likely you are going to like have more than 250 ringgit worth of components. And I find that the parametric search for Digikey is a lot better than Element 14. I find Element 14 really slow and difficult, but with Digikey, for example, you can have like tolerances, even like they want like a 25% resistor, or like the 1%, like the gold resistors, 10%, whatever. You can have like different kinds of resistors, the cement type or whatever. So it's quite a lot better, I feel.
Yeah. Actually, that's a good point. I think last year during the lockdown, you ordered. I think 250 is pretty easy to hit if you're doing a project, and then I think UPS from Nashville or something like that. some weird place right in the middle of nowhere. They ship
Yeah.
to you. I think within a week was pretty acceptable. Within a week,
They route through Alaska. Like your like thing. It goes to Alaska and then goes to Hong Kong and then goes like from Hong Kong to China to Thailand to Malaysia. So it's a strange route, but I find it's quite cool that they can give you free shipping above 250 because that's like from the US to Malaysia. That's quite cheap.
Yep, yeah. That's actually
Okay.
a good.
So okay, so let's move on. Let's say that you don't have an army of technician, engineer, or friend that will help you solder. So you need a soldering iron, right? How do you? Which one you get? Which one you will suggest people that want to try out start getting one?
Well, I mean, like, typically you start with something. Yeah, okay. Okay. Soldering iron is something where this is probably the worst one. Is like what I felt like a lot of people thought their soldering skills was very bad. In actual fact, it's actually they buy a, I don't know, like a 15 ringgit soldering iron, and then those are really bad. Plus nowadays with places like Mr. DIY selling those very bad solder leads, right? You know, like you can never get any soldering done, and also probably a decent one would be I don't know, in a range of like 50 plus. Recently, I found, I mean, like if you're doing light soldering, USB based soldering are not too bad. Those USB based soldering, are not too bad. They cost like, I don't know, like 25 ringgit or so. But while using that, I find unless you know what is a 1 amp USB port, if you plug into a half amp USB port, you are not going to get enough heat on it. And I think recently a lot of those, there's these two very popular soldering iron. It's called the TS80 and the TS100. Yeah, those are pretty popular. And recently there's this company called Pine. They produce
I'll put the link on the stream.
Yeah, they came up with one thing called a Pine Cell. So it's a TS100 compatible board. But the interesting thing was that it is running on the RISC-V MCU on the soldering board itself. Yeah.
Of course, the question there is
100 megahertz controller controlling your temperature. That's a bit.
The question there is, why do I need a 100 megahertz microcontroller Cortex AM4 thing, ARM M4 microcontroller in my soldering iron, right? What's the idea here?
So that you can smartly control the heat.
And
so it can run JavaScript. That's the thing.
So
the soldering can do, it has an accelerometer. If you put it down, it will auto shut off the heat for you.
Oh, okay.
Yeah, quality of life. Yeah, I guess the temperature control as well, depending on the things that you're soldering. Like, do you want it very hot or do you want it just nice? If you're, like, for example, doing an actual microcontroller soldering, right? You're soldering in a microcontroller. You don't want it to be too hot. If you're doing like very thin leads, you don't want it to be too hot, otherwise you'll burn it. If you're doing really thick copper pipes, then you want it to be like a bit, or maybe you need a blowtorch, but you want the control of the heat to be better.
Also, I think some people don't they don't know that there's for the soldering lead that is there's a ratio.
Yep.
So for beginners, what is the what you call it, the for the easiest to entry and easiest to find, but with a good quality solder, what do you recommend?
Typically, we will use just a normal 60-40 solder lead, and then use I don't know, the default one is actually like 1 mm. I prefer something that's 0.8, slightly smaller. Yeah, but other than that, we'll probably use a leaded solder, like. But most of the stuff that we buy nowadays inside have unleaded solder. Yeah.
Okay, so now, okay, I had an idea. I learned to design a board on KiCad. In between, I also read the datasheet to know what component I'm going to put on my board. And now I'm soldering it myself because I'm too cheap to hire an army of friends to hire. I'm cheap. So that would be so a project like this would be like, so that is just a prototype itself only, right? It's not something that you send to the customer, or you can already send it out to the customer.
Yeah, I mean typically, probably the first one, if it's like, typically you can send it to the customer as long as you have proper like connectors and proper secure connectors. Things
Okay.
like that. Yeah, it's usable.
But before you do that, you have to test and all that. Right? How do we test? How do you test something?
Testing, typically you do a bit of a burn-in test. What is you let it run for like a few days, that is also to make sure I think same thing for software testing. Make sure it's stable, like it doesn't crash or it doesn't overheat or some of your components is wrongly specs, they'll probably burn within a day, things like that. Second thing is also make sure your sensors, all the readings are normal and nothing too abnormal. Yeah, typically if it's pretty urgent, you just test it within 1 or 2 days. But a lot of times is about formatting the code and then getting lots of the time which I spend on the software side also.
Okay.
When is the time where you have to think about compliance? Like you mentioned about unleaded, for example. I don't think that would be RoHS compliant, but I don't think Malaysia needs any kind of RoHS compliance anyway. So like when in this process do you have to think about compliance if you're sending something to your customer?
For prototyping, probably no. But as I say, when you need to do like if you need some sort of a certification, yeah, that is where you probably have to think about compliance, because if you are connecting it to say for example Malaysia, the 220 main supply, right? They will run a bit of the all the weirdest tests they need to run is like make sure there's no spark going on. So this one we run it. It's kind of weird. It's like they will put your board in a chamber, a very high humidity chamber for 7 days, and then once they take it out, they will blast it with a 1,005 watt and a 3,000 watt, and make sure there are no sparks and things like that. Those are a lot of safety kind of standard. Yeah. So if you are dealing with 220, make sure your boards have enough of the separation by air separation. There's no way your board is going to spark if they're going to blast it with like 3,000 watt or things like that. So
Okay.
lots of those are mainly for safety purpose. So if you want to do a quick prototype, yeah, I'm probably not gonna care about that part of things. Probably later down when they want to manufacture, do a mass manufacture.
Okay.
It's for liability lah. So if the product is gonna be a consumer based product that you're gonna there's some customer outside there lah, then you have to get all this certified lah, everything. CE certification, your RF, your FCC, whatever certification, serial certification, all those kind of things have to be done.
Yeah.
But if it's just a prototype that is going to be used in house by a few people, then it's less stringent.
Can you still call it like a prototype? It just so happens to have 1,000 units in house. Is that allowed?
Nobody stops you.
Sorry, you're still muted.
At the end of the day, it's about liability. So it's about who's going to be responsible. It's like he says, if the thing catches fire and burns down the building, who's responsible ultimately? So as long as if let's say is you deploy 1,000 units of sensors, but all within one company, one client, right? The client has like a huge whatever facility or whatever, and that client is willing to take that responsibility for everything. Then you know, ultimately it boils down to the legal liability.
So which goes to my interesting question, because Stanley, you built the big installation for Singapore, right? The big art installation in Singapore. What's the difference between that and smaller project, and how do you make sure that you don't burn down the Art and Science Museum in Singapore when you install it?
Yeah, okay. What I find dealing with Singapore and Malaysia is a pretty big difference, because well of course we in Malaysia we just do things, you know, like, but when I was dealing it this one in Singapore, we are dealing with lasers. These lasers they are pretty safe for the eyes, but then being in Singapore, right, I have to put a barrier so that make sure people don't go inside there, and then if they ever do, I actually need a kill switch, like those you see in the CNC, you know, you hit it and then you cut off all the circuit, you know, so things like that, you know. So lots of very safety concern. Same for the outdoor one we did for Marina, you know, they say that, you know, you have to use a proper commando plug, you know, with a proper rating, you know, like make sure all your ampere ratings are all correct, and then your, you know, they have a little bit more stringent, but end of the day, these are all very safety, because they are dealing with the general public, and they didn't want the kind of liability that is happening. Yeah.
So you have to actually do more tests and make sure that things don't get.
And I got a comment from I did one more project in Penang, and then one of the Australian guys say that we will never be able to do this in Australia due to the strict restriction of, you know, like for us, we just take this electrical part and then we just wire them up, you know, as and when we like them. So not a lot of Western country probably, you know, like they probably can't get it off the door.
It's not fair, because in Maker Faire US they have a dragon, the Spitfire, for goodness sake. They literally had a dragon, the Spitfire.
Yeah,
probably cost them a lot of money to get that certified.
Yeah.
You know, even I'm going through some building certification. Even that is already pretty crazy.
Yes.
So
I mean, it's about making sure that you can escape, you don't die easily and all that.
To brief you on that is that there's I mean, we're doing an office renovation. The blueprint needs to be approved by the BOMBA, the fire department, and also afterwards they have to come go in for inspection. So both of them, they're gonna charge you for quite a significant sum. So yeah. Imagine having to apply to do this, and the time and the money you have to spend to get the approved.
But most people just don't do it lah.
Yeah. I mean, you probably can't make a fake dragon without people knowing, so you have to do it. It is a big dragon, a Spitfire, which is actually a real problem.
Like Son say, is I'm gonna twist his word. Like shifting the responsibility. It's
legal liability.
Yeah, so we can get the insurance to pay us back at least when that happens.
Yeah. Okay. Any question you guys will ask before I last? Okay. So my last question is, what's the difference between prototyping and sending it to manufacturing? Is there a difference for you? Your project is small enough that it doesn't really matter.
Well, I mean, prototyping is I think it will be very fast thing, so that you get it out the door, get it, especially if it's going to be like a hardware startup, right? Get it validated, you know, kind of like what was the what's the word is it? Yeah. So this is something that you want to get it, but for an actual manufacturing, you really need to go through a lot more steps, like bringing the cost down. Every unit price needs to go down. Every component, everything. If you can get a cheaper one, you need to get a cheaper one. But what I my one of my last project I find is very very amusing was that took us so long to get all the components price down, right? But then after that, we did a printing on the hardware. It was a color print. So when we color print the logo onto the casing itself, right? That itself cost so much, you know. Then I was thinking, you know, like why, you know. So of course, if you want to design a logo, make sure it's black and white. You know? It's easier to be print onto the board, print onto the even the metal casing or even like printing. Yeah, so getting a lot of the driving the cost down is one of the main feature if you need to get it manufactured.
Yeah. And I'm actually done with my question. Any question from you guys?
I just want to put one more point here, like what Stanley has mentioned a few times, that is the cost.
Yeah.
That's actually the biggest difference between dealing with software and dealing with hardware projects.
Yes.
Hardware projects are extremely cost driven. Everything boils down to cost, and cost is in dollars and cents. Especially if you're going to go mass production, then you know if one piece of one of your microcontroller costs 1 cent cheaper, you multiply that by a million pieces, or actually it's quite a significant amount of money, that kind of thing. And this is like real story. Some of my friends tell me like I got a friend working in Dyson. They're like they have to spend a lot of time trying to solve a problem. Then they come and ask me like how to solve this problem. Then I told them, simple solution, just upgrade your processor right, to this processor. Then they're like, cannot, that one costs like 50 cents extra, cannot. Then I said, but then your developer time is so much more effort. They say, but the amount of money is still a lot less than the 50 cents extra. 50 cents extra times by how many units they make, you know, like tens of millions of units, or they can afford to hire a lot of developers. So
unless you're selling missiles.
But that's the kind of thing, like everything is very cost driven in hardware. It's the exact opposite of software. Software is like it's a lot easier.
Software is easy. Software is like when we put it to production, quote unquote, we opening in a port in public and you just come in and you just spend like $1 extra on AWS for a big instance, and that's probably it.
Scaling.
Right?
And with software, production isn't actually production. Production is also just a prototype, right?
Yeah, it's prototype, but the port is in public, right? That's it.
It's a prototype that we've decided to call production for now.
Yes. So there's a big difference between software and hardware. I know I have a lot of idea about what we have today, but I don't think I can cover it all.
That's probably one of the reasons why you can't really get insurance. You can't claim insurance for like a breach or something. I don't know what the state is right now. Like for example, if someone like I don't know, like breaks into your system and somehow like steals all of your users' data.
I think it depends whether there's a person, there's a company who willing to take.
That's the thing. Yeah. That's right. That's the difference, like the biggest difference, because in hardware, like in when you're doing it in production, you have all of these certifications, compliance, that insurance has an easier time because everything is standardized. You have like, okay, you're complied with all of these government regulations, etc., etc. We know what to pay for it because we know what to expect because this has been studied a lot. Whereas for this, you have to actually do a Exactly. Yeah, you have to do a custom agreement with an insurance provider. Hey, look, and then eventually they actually have to inspect all of your things. Do you comply with it, something, etc.? Because in software, at least at this state, we don't have this kind of compliance thing. It's exactly the same. The legal liability rests on whoever is deploying it. It's not like if you're contracting with your client, the client basically bears all of the responsibility. You as a developer, software developer, does not have anything to do with it. Even if you're very, very bad at designing it, your client still is the one who pays for all of your mistakes. So that's the thing.
Yes.
Unlike, for example, in hardware, if you make a mistake and your 220 volt has a spark or cannot handle like a sudden surge in a house and it causes a fire, because somehow you passed certification, then you have no liability. But if you did not pass certification, you have the liability for selling a bad product. So that's I think a big difference there.
Yes. So
I don't think there's so
think-
much a difference between software and hardware, but rather a difference
Yeah.
between whether it's a professional
I think
endeavor
it's-
or a non-professional endeavor,
I
where
think
you
it's
have
gonna be-
personal liability
gonna-
attached in
I think it's
addition
gonna be more
to
regulated soon with big breaches over
Yeah.
especially last year.
software. Definitely will have to be regulated soon. Actually, I've been telling all the young engineers who are coming up to get themselves registered, get themselves properly done, because but for old timers like us, maybe by the time it comes in, we are all like retired or whatever. But for the new ones coming in, they will still be in the industry in their prime, and they will have to. It will have to be regulated. Cannot run from it.
Yes, correct. So there'll be practices and all that, but that's another story. So there's a lot I did that I want to cover for basic electronics. I will cover. But that being said, check our website. I put some links. They put some links of basics that you want to know when you want to hack a product and electronics.
I think I want to.
That
I'm gonna ask another episode with Stanley about a ham radio.
yeah, that's
It's
another
a
one.
topic that not many of us are familiar with.
Yes.
Yeah, sure.
I will get a few guys as well, and that will be after this set after this electronic set one day. So thanks for listening. I will update the note with some extra link that I forget to add. The soldering one and soldering one and keycap. So I'm going to add the links. But today's episode, blog page also had a few links to the basics already. So it covers like the element, Adafruit learning system and all that. So you can go there if you want to learn a bit more about electronics, and also link to a book. The book is called. Let me open it. It's called Hardware Hackers by Bunny Huang. I recommend this book because it gives you. It will ground you. It will ground you to the world of hardware hacking. And also he had extensive experience in hardware startup. He's the one, he co-founded a hardware startup. Then later he's in Singapore and he go to China for manufacturing all that. And he hacked the Xbox. He hacked the original Xbox. So I recommend him, and he will ground you to the reality of hardware startups and all that. So it's a good read. I recommend that. So go to DevKami site. The links will be there. So
I've shared another link to a pretty good book for people who are starting out with electronics. If you want to pick it up, don't really need a solid electronic background. In the private chat, I put a link.
I'll put it on the links, and then we can add it on on the what do you call this?
I'll just add it. I just added it to the public chat.
Yeah.
So I
How
guess we
about
need
Dr.
to,
Sean's
click the link.
book on FPGA? When are we getting Dr. Sean's?
It's not done yet. It's not done yet.
Another episode of Sean up here introducing his book.
When the book is done.
Okay, so next week, before we really gone, next week we'll cover sensors, input, output. Maybe there'll be something more substantial with code and all that. Let's see. Then after that, we'll cover actual microcontrollers. So the series is just beginning. So with that said, I think we should say goodbye now. Should we?
Yes.
So yeah, we should say goodbye now. Chinyang, come on and say goodbye.
Bye. See you next week.
Bye. Thanks for coming. I hope
Like
this
and
is
subscribe if you haven't.
Yes. It's up down there somewhere. All right.